Okay, so in this video I'm basically gonna talk about intersections of planes. Let's say we have the plane 2x plus 4y plus z equals 13, and we have another plane 3x plus y plus 3z equals 6. So now when you have this, the coefficients of x, y, and z will give you the normal vector of that plane. So what basically means n1, we'll consider this to be plane 1. Let me just write it. So this one will be plane 1 and this one will be plane 2. The coefficients, if you're looking for the normal vector of that in direction vector form, you just take the coefficients of that, and then this basically implies like, yeah, you'll have a normal vector 2, 1, and 1. That's a vector perpendicular to that plane. And then if you're looking for the normal vector of plane 2, it's just a similar process. Nothing changes basically. So it's just going to be 3, 1, 3. So you can do that for every other plane. So that's how you get the normal vector if you're provided a plane. It shouldn't stress you out on that. Remember, first I showed you how you get the equation of a plane. You get the normal vector in just one point that lies on the plane. Then you can get that equation. So from now, I'm just showing you like getting the normal vectors if you have the planes there. So now let's talk about the intersections of planes. So if two planes intersect, they'll definitely intersect in a line. So that's what you need to keep in mind. So now what we want is to find the intersection line. So when we find the intersection line on these two planes, you remove one variable. You just eliminate one variable. Okay, as of let's just say this one is 4y for simplicity reasons, and this one becomes 4. Okay, so now we want the intersections of these two planes. So what do? We want to eliminate one variable. Okay, I choose to eliminate z from here. When I choose to eliminate z, that means you just solve for z in one plane. So it's easier to solve for z in this plane here. So because z will basically be 13 minus 2x minus 4y. That will be the value of z when you solve for z in the first plane. But now I'm eliminating z. What do I do? Multiply plane 1 by negative. We just basically want to eliminate z, so that means here we must have minus 3z. So when we add the two planes, we can cancel z out. So multiply plane 1 by minus 3. So you'll have minus 6x minus 12y minus 3z. This will be equals to minus 89. So that's what you'll have. And then the second plane, you keep it as it is. 3x plus y plus 3z is going to be equals to 6. And then from then you just add the 2. Minus 6x plus 3x, that's going to be minus 3x. Minus 12y plus y, that's going to be negative 11y. And then this one will cancel out. And then minus 39 plus 6, that's just going to technically give us minus 33. And then you can like remove the negative from there, and then you get 3x plus 11 y equals 33. Now we want to find, this is the intersection line. This is the intersection line. This is the line that these two planes will intersect. So when these two planes intersect in this line, choose x equals 0 in this line. If x equals 0, what's the value of y? You plug 0 and you solve for y in this case. You plug 0 and you solve for y in this case. So when you solve for y, you get y equals 3. And then we solve for z in the first plane. Then we find the value of z here. If you plug x 0, y 3, you'll get the value of z to be 1. Also, you can also choose another coordinate. You can choose any coordinates you want. I'm just choosing the coordinates that make my life simple. So I can choose x equals 11. If x equals 11 here, plug x equals 11, you get y equals 0. And then after that, you find the value of z. That means you just plug x equals 11 and y equals 0 on this line. On this plane, and then you find the value of z. I find the value of z to be minus 9. So another thing you should keep in mind is that sometimes I make mistakes when doing this thing. So just keep in mind that the process is the same, really. But if I made a mistake doing something, just correct that and work on that. So now I have two coordinates, 0, 3, and 1, and another coordinate, two coordinates. This is the first coordinate, and another coordinate 11, 0, and minus 9. So remember, this is the intersection line of the two planes. Now, what if they are looking for the parametric equations of where these two planes intersect? Basically, we're looking at these two planes. So where do these two planes intersect? Let's say they want the parametric equations of where the two planes intersect. So from these coordinates that we just found, we're going to get a vector from that. So you can just choose this one as your terminal, and this one is the initial. So you'll have, you obtain a vector. Let me just write it like that. So you obtain a vector v. So 11 minus 0, that's 11. And 0 minus 3, that's going to be minus 3. And then minus 9 minus 1, that's going to be technically minus 10. So you get a vector from there. Then you just pick one point here, either this one or this one. Then you can write the parametric equations. If you forgot what parametric equations are, it's something like this. X naught plus AT, and y equals y naught plus BT, and then C equals z, sorry about that, z equals z naught plus ct. So now we want the parametric equations of a line where these two planes intersect. So what we'll do is I choose this one to be my coordinate set. So I have x0, y0, and z0. So that means that x will be equals to, since x0 is 0, you're just going to have 11t. And then y equals, y naught is 3, and then minus 3t. And then you have z naught is 1, and then you have minus 10t. So that's basically what you're going to have as the parametric equations of the intersection of the two planes. This is the parametric equations. And then if you're looking for the symmetric equations, remember the symmetric equations is x minus x naught over a equals y minus y naught over b equals z minus z naught over c. So basically the symmetric equations of that will technically be remember this is x minus 0, so x naught is 0. Remember it's x minus 0, which is just x over 11, equals y minus 3 over minus 3, and then is equals to z minus 1 over minus 10. So that's technically the symmetric equation of the intersection of these two planes. So these two planes will intersect in this line, and the parametric equations of that line is this one, and the symmetric equations of that intersection is this one. So you can basically play around with these things. So that's about intersection of planes, and don't forget that these coefficients will give you the normal vector of that planes. Good luck.